our quiz review. And here it is. And specifically, the question that we were asked to look at was number 4. John was given the coordinates of 3 points and asked what type of triangle is formed by the points: acute, right, or obtuse. Which of the following gives him the best chance of finding his answer? Okay, so here's what he needs to do. If he's asked to, and can you guys see my piece of paper now in my hand? Yes, hopefully. Okay, if he's asked to find out whether a triangle is acute, right, or obtuse, what that comes from is, and this is something we did, I don't know, November-ish, is the Pythagorean Converse. Okay, the Pythagorean Converse is what we use to determine whether something's acute, right, or obtuse. And what the Pythagorean Converse says is, if c squared is greater than a squared plus b squared, it's obtuse. If c squared is less than a squared plus b squared, it's acute. If c squared is equal to a squared plus b squared, it's right. Okay, so this is what we want, is we want to be able to compare c squared to the sum of a squared and b squared. All right, now when we're talking about Pythagorean converse or Pythagorean theorem, a, b, and c are side lengths. So this means we need distances. So we have to do distance formula. So I don't want the slope formula, and I don't want the slope formula. I don't want A or B. The only thing A or B would help me find is if I had opposite reciprocal slopes, it would help me see that if it was a right triangle. But it wouldn't tell me if it was obtuse or right. I mean, it wouldn't tell me if it was an obtuse or acute if it's not right. I would just know it's not right. Okay? So the best chance of finding out whether it's acute or right or obtuse comes from something that would tell me all three of them, not just something that would tell me whether or not it's right. And A and B, using the slopes, actually, specifically A, would just tell me if it's a right triangle or not. B is not going to happen because you can't have equal slopes, because you can't have two parallel sides in a triangle. In a triangle, you only have 3 sides and they all meet. Can't be parallel and also meet. Okay, so it has to be C or D because it has to be distance formula. The difference between C and D is C says use the distance formula, compare the sum of the lengths of the 2 smaller sides to the length of the largest side. D says use the distance formula, compare the sum of the squares of the lengths of the 2 smaller sides to the square of the length of the larger side. And D, the part about squares, that's this. I'm taking the sum of the squares of the 2 smaller sides and I'm comparing them to the square of the larger side. C just says the sum of the length. That's not going to tell me, because that's not what the Pythagorean Converse says will tell me whether it's acute, right, or obtuse. The only thing this would tell me is if it can be a triangle or not. Remember, that's the triangle inequality, is any 2 sides have to add up to be more than the third side. That's just, can they touch to make a triangle? Okay, but to find out whether it's acute, right, or obtuse, this is what we need to do. So we need to take the lengths of the smaller 2 sides squared and add them together. So the sum of the squares of the lengths of the smaller 2 sides, and then compare that to the square of the length of the larger side. So it's basically just a verbal statement of the Pythagorean Converse. That's what D is.
Okay. Also for 9, I realized what I did wrong.
Okay, let's just talk about it anyway. It's a good one to talk about. And Michael's here, so you know. Michael's given 4 points and asked to figure out whether or not the resulting parallelogram is a rectangle. Which of the following can she use to show that in the fewest steps possible? Okay, so if it says whether the resulting parallelogram, they're giving me that it's a parallelogram. So it's given that it's a parallelogram. That's important. Okay. So given that it's a parallelogram means all 5 properties of parallelograms are already going to be true automatically. That won't help me find out if it's a rectangle or not. So I'm just drawing. Well, that's pretty bad. Let me show you what I'm drawing. These are the 5 properties of parallelograms. And this is not a very mathematical way of representing this one because there's not one. Okay, so opposite sides are congruent, opposite sides are parallel, diagonals bisect each other, opposite angles are congruent, and consecutive angles are supplementary, meaning 2 angles next to each other add up to 180. So the fact that they told me it was a parallelogram means all of these things are already true. Okay, so looking at A, it says find the slopes of 3 sides and see if there are any opposite reciprocals. Well, opposite reciprocal slopes tells me that I have a right angle. So that could be helpful because if you have a parallelogram and you find that you have one right angle because of this, if one of these is right, then automatically, because of these 2 things really, then automatically all the rest of them have to be, because opposite angles have to be the same and consecutive angles have to add up to 180. So if I found that I had one angle that was right, that would be sufficient to say it's a rectangle. So A is a good possibility. Okay, so I'm going to keep reading, but A is a possibility. B says find the midpoints of the diagonals and see if they're the same. Well, if they are, that means it's a parallelogram, which I already know. They have to be because it's a parallelogram. That's proving that diagonals bisect each other. Okay, if the midpoints are the same, it shows the diagonals bisect each other, and we already know that if we already know it's a parallelogram. So B does not help me at all. C, find the slopes of the diagonals and see if they are perpendicular. Okay, well, slopes being perpendicular is a thing. That means, like, is this a right angle right here? Or is this a right angle right here? But the place that they're a thing for is rhombi. That's a property of a rhombus, which means it's also true for a square. It's also true for a kite. But none of those are the things we're trying to prove. So if we found that the diagonals were perpendicular, that wouldn't help me prove it's a rectangle, because this is something that's true for a rhombus, which means automatically true for a square, and it's true for a kite. But in this particular case, we know for sure we don't have a kite because we have a parallelogram, and kites are not parallelograms. So C would not help me at all. D says find the lengths of the diagonals and see if they are the same. Okay, so the lengths of the diagonals, let me see if I'm going to show this. Basically, lengths of the diagonals, that means this whole length is the same as this whole length. So not this, not diagonals bisect each other, but just the lengths are completely the same. However, since we already know it's a parallelogram, and we know that diagonals do bisect each other in a parallelogram, if the whole length were the same, like let's say that this whole length was 10, well, that means this whole length would be 10. So really all these little pieces would be congruent. So that is a property of rectangles, is that diagonals are congruent. The 2 additional pieces of info that rectangles have that not all parallelograms have are 4 right angles and congruent diagonals. So D is also a possibility. So really the question just becomes which one is in the fewest steps. I would probably, I'm honestly questioning what I said here, because I would normally, I would say probably 9, or I would probably say D. Yeah, I did say D. But I think you actually could make an argument that A might be easier just because slope formula is quicker. So you can make a good argument for A on this one as well. Okay. The thing about A is that there's additional You're doing something additional there you don't have to do. Well, no. Yeah. All you need is two sides. Yeah, if you found the slopes of two adjacent sides, and see if they're opposite reciprocals, that would be it. So A kind of has, and that's what my thinking was when I was doing that, is that it's not the fewest steps possible because you're doing it for three sides and you really only have to do it for two sides if you're going with that route of proving that I have a right angle. But if we were comparing those two methods and saying which one is faster, I don't know that I definitely would think D is faster. So D or A is fine there. But more important is to understand all the stuff I just said. Other questions on here? Any other ones you want to go over? Yeah.
Am I supposed to be seeing something on the screen? Because mine's not showing up.
Yeah, you are supposed to be seeing something. Does nobody see anything? It says that I'm sharing.
Yeah,
I just stopped.
I see it.
Okay.
Okay, you did? Okay, let's see. Let me go back. So you did, like, were y'all seeing it when I was jumping back and forth from the quiz review to the paper?
Yes, yeah.
Good.
Yes.
Okay. That was my plan. I'm sorry that, who was that? Taylor? Who was that?
Oh, that was me.
Who's me?
Grace.
Grace? Hey, Grace. Did you see it now, or are you seeing anything right now?
Yeah.
Good. Okay.
Okay.
All right. Yes. Here's my review. This is what I'm showing. Other questions you want to go over on here? Any?
Yeah, I just checked 10 and 11, yeah.
10, 11?
Yeah, yeah.
Sure.
Well, I just checked it.
Oh, and you're good?
Yeah.
Okay.
I was like looking back while you were like doing 4 and 9. I was like looking back and forth between the video and like the key at the same time.
Okay, good for you.
Yeah.
Anybody else want to see those? Okay, let me give you another problem that I thought about putting on here but did not. Let's see. Okay, so you are given 3 vertices. Yeah, they're supposed to, the S is supposed to be right next to the E. Not sure why that happens. Sorry. 3 vertices of a parallelogram. And this was similar to one you did on the quadrilaterals one with the rectangle. Find, let's go with all possible values for the fourth. Okay, so given 3 vertices of a parallelogram, find all possible locations for the fourth vertex. So I'm going to say that my 3 vertices are A, -1, 1, and B is going to be 3, 5, and I don't want you to think about the letters having to be in order. They don't have to be in order. So I'm going to jump ship in terms of alphabet and call that Q is 7, -2. So you're trying to find another point that makes a parallelogram with those 3 points. And there's more than one possible answer. So let me give you some time to play around with that. You guys ready to talk about this one?
Almost.
Almost. Okay. Can I give you a hint? Do you know how many? Does anybody know how many possible locations there are for the fourth vertex?
3?
There are 3 possibilities.
Yeah.
Yep, 3 possible locations. I haven't gone any further than that. So let me go ahead and just show you that so I can keep working. These are my 3 possible locations, and I'm going to make this smaller so that you can see all 3. Those are the 3 possible locations. Like the X marks the possibility. Have you guys got your points?
Yeah.
Okay, let me. And I kind of did them different ways. There's not like a formula or anything. It's kind of like you're using sort of a combination of thinking about slope and thinking about distance. It's basically how far over left or right did I need to go for this line, and how far up or down did I need to go for that same line, and then we can use that to get to a spot that has the same slope and the same distance. So I got for my first one, I got 11.2.
11.2. I got 12.2. How did I get that one?
To go from here to here, I go right 4 and up 3. So I went from here, right 4
Okay.
and up 3.
I did 5 for some reason.
And then the next one I got was -5.8. And that one I did kind of I figured out the slope was -3/8. So in other words, I have to go up 3 and left 8 to get from this point to that point. So I have to do the same thing here. And here I did it kind of like a translation. Like to get from this point to this point is x plus 4, y minus 7. So I just did plus 4 minus 7. Same thing. So in other words, plus 4 minus 7 plus 4 minus 7. Interesting how those all make like triangular pyramid look, triangular prism looking things right now. But those are kind of fun problems to do with coordinates, with parallelograms, is finding the missing side or the missing vertex. Okay. And really, when I say it's like a combination of distance formula and slope, remember that you have to have the same slope and you also have to have the same length. But when we think about the numbers we use for slope and the numbers we use for distance, really they're the same numbers. Okay, we need to know the difference in the verticals, and we need to know the difference in the horizontals. So we can use that to find slope, or we can use that to find distance formula. When we do slope, this is the difference in the verticals, and there's the difference in the horizontals, which sometimes, like in physics, we write that as change in y over change in x. And in distance formula, you got the same thing going on in here. This is the change in x squared plus the change in y squared. So either way, what you're really using is what's the difference between these points left to right, and what's the difference between these points up and down. Questions on those? Or other types of problems, maybe from the review or from any of your homework that you want to look at? Do you want to go ahead?
Oh.
Go ahead.
Can we
Go
do
ahead.
another one of those type of problems?
I'm sorry, say it one more time.
Can we do another one of those type of problems?
Oh, the ones we just did?
Yeah.
Sure. Okay, so let's come back here. So given 3 vertices of a parallelogram, find all possible locations for the same vertex. So assume we've got the same directions, and I'm just going to give you 3 new points. Okay, I don't like that, so I'm going to go here. So same directions, new points. And I don't know why that's so poorly focused. I'm having issues with these things, with this particular dot cam with focusing. Like when it focuses, I don't think it's the best focus, but that's okay. It's close enough. Let's say we've got those 3 points. Okay, so see if you can find the 3 possibilities for another point or another vertex that would make that shape a parallelogram. You guys ready? Need more time?
I'm good.
Let me know. Let's put it this way. Let me know if you want more time, and I won't tell you.
A little more time, please.
Okay, sure.
One more time.
Awesome. Thanks. Okay, ready?
Yeah.
Okay.
Yes.
So here is one. 7, -9. And then another one is -7, -3. And then another one is 1, 5. How is that?
Good. Yeah, much better.
Did you get them?
Good. Thank you.
Okay, what if I give you a couple of problems,
Got it.
like 10 and 11 on the review, but different problems to try now?
Yeah, I can do. We can do it. Yeah.
Cool. Okay. So let's suppose we have points. Let's say we have, hang on. Oh, there's the message. Just saw your message, Rebecca. Okay, so somebody's got some noise coming through. Some sound, and I'm having trouble figuring out. There we go. We're good. Okay, so
Rebecca,
yep.
are you talking? I can't hear you. Hold on.
Hang on. Might be my fault. Can you hear me now?
Yeah, I can hear you now.
Okay. I was playing with the sound.
Okay.
Okay, so let's suppose we have a segment. Let's call it MN. So we're assuming that M, it's like directed from M. So M's the starting point. So there's one. See if I can give you a better screen. There we go. So two problems. Are you guys ready to check them? Say no if you're not.
No.
Okay. I will wait for you. Sounds like a song. I will wait for you. I'm trying to draw my picture and it's not working very well. I don't like any of them. Okay. So looking at the MN one, here's MN. And if the ratio is going to be 3 to 1, that means, and I'm starting at M, there's a total of 4 pieces, 3 plus 1. So I'm going 3 out of 4 pieces and then stopping. So I'm dividing the whole thing into 4 pieces and stopping 3/4 of the way. Okay. Remember, this comes from adding these two together. So 3 plus 1. All right. So basically, I'm thinking of dividing this into 4 pieces, and I'm going to the point that is 3 out of the 4 pieces of my distance. So basically what I'm doing is I'm starting at this X and adding 3/4 of the whole length. Well, the whole length in terms of just X, which is the same as saying the X, the horizontal distance, is 1 minus -7, which is 8. So for X, I get -7 plus 3/4 of 8, which is -7 plus 6, which is -1. Okay. So that's like going 3/4 of the way in terms of X's. Now for Y, I'm going starting at 3, and I'm going 3/4 of the way to -1. So that distance from 3 to -1 is -1 minus 3 is -4. Okay, so that's like I'm saying I'm going down 3 out of the 4 pieces in terms of Y. Okay, so 3 plus 3/4 of -4 is 3 minus 3, which is 0, and my point is -1, 0. Excuse me. Questions on that one before we do the next one? All right, next one. This time I need to go 3/5 of the way from A to B. Okay, so starting here, -3 plus 3/5 of the way means of the distance between the x's. The distance between these x's is 7 minus a -3, which is 10. What?
I can't see your screen anymore.
Can other people still? I'm not sure what's happening.
I can.
I can still see
I
it.
haven't changed anything. I'm just writing.
It's back.
So this is -3 plus 6, which is 3. And then the same thing for the y's. I'm going to start at -4 and then go 3/5 of the distance from -4 to 1. From -4 to 1 is 5. 1 minus -4 is 5. And so that's -4 plus 3, which is -1. So 3 -1, somewhere like about there, is 3/5 of the way. So in other words, there are 3 pieces before it and 2 pieces after it. So that would be the same thing as saying divide it in a 3-to-2 ratio. Kyle, can you see it now?
Yeah, I can see it now.
Okay, cool. Questions on either of those?
Could you do the segment MN again? Or just to go back to showing it?
Yeah.
Okay.
Got that?
Yeah.
Okay, well, we are a little bit past our ending time, but if anybody has any other questions, we could go ahead and talk about them, or I can let you guys go.
Thanks, Ms. Backfish. This was really helpful.
Oh, good. I'm glad. Okay, so I'm going to post the quiz to be open like all day from like 12:01 to 11:59. It'll probably have like maybe an hour time limit, but that's what you're doing tomorrow. So you already know. Okay?
All right.
All right, let me know if you can still email me or remind me any questions you have, okay?
Okay.
Okay.
Okay, thanks for coming, guys.
Okay, bye.
Bye.
Bye.